Hello, welcome. Good morning, good afternoon, good evening, depending on wherever you're joining. Welcome to this webinar on platform engineering. For next half an hour or so, I'd like you to give you an overview of what is platform engineering, why is it needed, and how to get started. My name is Pani Bhushan. I work as a technical consultant at Devon, based out of Netherlands. Imagine you decided to go on a nice vacation. So you booked your flight, you went to airport, you dropped your bags, and you're now waiting for the flight so that you can board. If you recollect, you already used a bunch of services from the airport, things like getting a boarding pass, clearing your security, and perhaps buying one or two things while you wait at the airport. From an airline point of view, well, their primary objective is to take you or passengers from destination A to destination B. But to do that, they also need a lot of things, someone to load and unload the bags, fuel, some people to clean the aircraft. Imagine if, for example, a KLM flight, if they are traveling from, let's say, Amsterdam to Bangalore, and if they have to make sure all those services are catered to them, every destination they go to, that becomes a nightmare for an airline. So instead, what they do, they depend on each airport for services like, a staircase for passengers to get on and off aircraft, fueling trucks, so on and so forth. And these services, irrespective of the type of aircraft, it could be Boeing 737 or a Airbus A380, doesn't matter. An airport provides these core services to all aircrafts. And if you look at a different analogy, I recently bought a nice coffee machine. It's really good. I love coffee, so I love drinking coffee. So when I bought this coffee machine, of course, for me to use it, I had to plug it in. The moment I plug it in, I expect this equipment to get electricity. And I don't care, or I don't need to worry about how that electricity is generated, how it is transported from wherever it is getting generated to my house. All that infrastructure is maintained by someone else. And that is precisely the whole essence of platform engineering in a nutshell is. If you look at large IT landscape, typically there are different type of teams, could be application development teams, info security, or operations. They depend on some core services. Think about services like pipelines or the infrastructure where they need to deploy their services or products, ability to monitor those services, and also the security, identity, and authorization, but also certain services which are provided from a platform point of view, like, for example, ServiceNow or API platforms. Now, for these application development teams or security teams or operations, their end objective is to actually deliver business value. In same way, like the primary objective of a airline is to transport people from point A to point B, the primary intent of teams is actually to deliver new functionality or make sure the existing functionality is running as expected. To do that, the way airlines depend on services like baggage handling, security, refueling, etc., they also depend on certain services like pipelines, infrastructure. The same way, if each airline has to arrange those core supporting services on their own, it is going to be a nightmare. In the same way, if each application development team or if each operations team has to take care of their underlying services, then it is going to be a nightmare. For example, everybody wants to set up a Kubernetes cluster because they want to deploy an application, or everyone has to set up their own monitoring tools. It's going to be a mess. And that's precisely where platform engineering comes to rescue. Now, why platform engineering? Because if you look at large enterprises, there are a lot of friction elements. So I like this quote, which talks about friction is something that makes easy things difficult and difficult things impossible. Now, if you reflect on your own organization, what kind of friction elements do you notice? The typical ones that I have seen are things like where a team is responsible for delivering end business value, but they have to deal with wide variety of technology landscapes. Like, for example, if they are developing an application on Java or C Sharp, they not only need to focus on that and their application design and architecture, but they also need to worry about ensuring their underlying infrastructure is secure, reliable, and it is adhering to whatever compliance standards that as an organization they have set forth. So that becomes a big challenge for a lot of teams, that they have to focus on delivering business value, but also taking care of all the underlying infrastructure and respective SLAs. The other friction element that I commonly come across is planning dependencies. Let's say you want to deploy a new service, and for that, you probably need a new production environment. It could be like a Kubernetes cluster or a plain old vanilla virtual machines. Uh, and for that, you probably need to ask some infra team, hey, can you provide me a test environment or an acceptance environment? And if that takes a lot of time, I mean, I've seen instances where it takes weeks, if not months, for a team to get a new environment, that becomes a huge planning dependency that I need to tell teams much in advance so that I can do my work. The other kind of dependency or friction elements that I've seen is lack of standardization. Like a simple thing like, how do we promote our changes to production? Like, what kind of quality gates do we need to have in our pipeline? How do we deploy changes to production? Like, is it going to be like a, so some teams might depend, oh, we are going to do in this way, and some other teams might decide, oh, we are going to do it in a little bit different way. So what is the problem in that? The problem is everybody actually start reinventing the same wheel. So how do you basically minimize and eliminate these frictions? And that's where platform engineering comes up with an approach where the commonly used services and underlying infrastructure is provided as a self-service API tools and supported with proper knowledge, so that there is a very nice developer experience for people who consume those services. And what does it lead? It basically leads to higher pace of delivery of business value, because the teams which are focusing on delivering business value, they don't need to worry about all the underlying infrastructure needs. Well, it's not only about not worrying about it, but also ensures that whatever services they consume, which are provided by a platform team, are also adhering to all the compliancy and standards that are set forth by the organization. So that, in a nutshell, is what platform engineering. It is about a compelling self-service way of consuming services. Could be infra services, could be network services, IAM. You think about any core building blocks that are needed for application teams to deliver their business value is something that is delivered as part of platform. Now, when it comes to platform engineering, there are certain core values. Like we discussed with the airline example, or for that matter, the power distribution, you don't build the whole power distribution network just to serve one house or one business entity. Typically, it is done so that there is a huge leverage. In the same way, one of the core values of platform engineering is you build platform services which can be consumed by multiple development teams. Let's say, for example, I provide pipeline as a service, which means there could be different teams, someone using Java, someone using Go, someone using C Sharp. All of them can consume pipeline as a service. Of course, it is the same way. Like for example, if I'm uh, a, a airline, a small airport where I only operate the smaller aircraft, then the kind of infrastructure that is needed is a little bit different. But if I go to a larger airport where the bigger planes like A380 has to land, then it requires different infrastructure. So the leverage is key, but it also depends what services is primarily driven by the organization needs. The next one is ownership. So the platform teams which support by self-service, they enable all the teams which consume those services to live by the DevOps principle of you build it, you own it, because they also guarantee certain level of reliability on this platform services that they offer. The other core value of platform engineering is these platforms should be metric driven. So if you go to, for example, Schiphol Airport, there the kind of metrics they probably measure is also, how long does it take for someone to clear security checks? How long does it take for a plane to get refuel? How long does it take to unload or load luggage onto an aircraft? In the same way, a platform also has to be metric driven. Things like how long does it take to onboard a new team? How long does it take to, let's say, spin up a new environment? So it's always metric driven. So a platform should have those core metrics in place, which also sort of drive towards the success of that platform. Just like any new product development, it also involves continuous evaluation, because depending on your customer needs, you also need to improve your offerings of the platform, hence treating the platform as a product, which also goes with the innovation and operation excellence, which has to do with, if I'm providing certain services, I need to ensure that the SLAs that I have agreed upon are always met, and as a platform team, you are in control. So these are some of the core values of platform engineering. Just like an airport or a power transmission grid, like there are certain core building blocks, like you should have like a check-in desk, you should have a place and the necessary infrastructure to do security checks, some shops for travelers to do shopping, and the infrastructure to fuel aircraft, your runways. So those are like core building blocks when it comes to operating a airport. In the same way, when it comes to platform engineering, there are certain core building blocks. So what are those core building blocks? The primary one is automating your infrastructure and using infrastructure as code, which also means that the services that are offered are also reliable, which means there is a robust observability and monitoring capabilities in place, and ensuring that you start offering your platform services starting with the most used ones. So that's what we call here as golden paths. So golden paths are most commonly used services in a predefined way. And just to give you an example of what a golden path could be, if someone wants to start developing a new application, you can give them a stack. Hey, if you use, let's say, a LAMP stack or Java stack, then you get the underlying pipelines, infrastructure, whatever database that is part of it, the whole end-to-end is provided. And if you use it, everything is set up for you. And another core building block is the ability to provide the platform services in a more self-service way. I mean, one of the main intention of platform engineering is to minimize the friction. And one of the ways to do it is by enabling self-service. I mean, what good is if you have services where if someone has to fill in a ServiceNow ticket, which has to get approved and has to be routed, and maybe after a couple of days or weeks, if I receive service, that's definitely not a self-service. So a self-service is something where some APIs are exposed, or maybe a command line prompt or CLI, where the application teams or consuming teams can actually integrate in their pipelines or in their SDLC cycle. And another most important building block is thinking about various operating models and governance structure. So, like I said earlier, platform engineering or platforms in that sense are also should be treated as products. When you have a product, you also need to think about various operating models, like how are you positioning your platform, what are various ways how the users of your platform can get on it. Is it like, for example, pay as you go or a monthly subscription? Even though we are talking about your internal developers who are going to use your platform, you also need to think about how are they going to consume your platform. And most often neglected part, which is a little bit sad, is the whole idea of developer experience. I mean, you are building platforms and your primary users of platform is going to be your developer community. You need to make their life so easy that they get best experience. I mean, we talk a lot about customer experience. In the same way, developer experience should be thought in the same vein. Like if I am a developer and if I want to start using a platform services, it should be so easy and it should be very well documented so that I as a developer need not to think twice how and what I should use. And one of the most important building block is compliancy automation. Like I mentioned earlier, it is no good if every team has to worry about compliancy requirements. Yes, they do need to worry about it, but the things that can be taken care more at a platform level, let's say, for example, disaster recovery, the policies that needs to be in place. How do you ensure the CIA ratings are adhered in terms of the underlying data encryption, or, for example, the network stability and those kind of things? Those are the concerns which can be easily offloaded to a platform team so that the benefits can be reaped across the organization, whoever consumes those platform services. And the last but not least is the change in organization and its culture, where treating platform is one of the core essence of faster value delivery. So the culture also indicates on how various interaction modes takes place between the people who deliver business value and people who support, in this case, platform teams who support and make sure the business value is delivered at a faster pace. So these are some of the core building blocks when it comes to platform engineering. Now, so like I mentioned, we at Devon has implemented this platform engineering at multiple organizations. And one of the ways that we approach implementing platform engineering, especially at large scale enterprises, is this 6-step process. We start with the initial phase, what we call it as discovery and sponsorship phase. So this is the phase where we basically try to identify where is the burning issue or where is the most friction point within the organization. Your usual suspects in this area could be something like identity and authorization. The other place could be your pipelines or provisioning underlying infrastructure. So these are typical places where we look at. And of course, we also try to identify who is the right sponsor and who is the right level of leadership who can support it. Because as I mentioned, platform engineering touches on a lot of core elements of an IT organization, all the way from design and implementation towards maintenance and the whole lifecycle management. So hence, having a right level of support in the organization is very key for a successful platform engineering implementation. And next step is we basically assess the current pain points of both the developer community but also the stakeholders who are responsible for ensuring smooth business value flow. And once we do the assessment phase, then we formulate or strategize the platform vision, which is in line with the overall IT strategy. What I mean by strategize is also helping organizations to see which platform services that we need to basically provide, which ones need to be governed at what level. Those strategies are thought about and put in place, which leads to the next stage, which is the modeling phase. Like once we identify what is the right platform, how do we approach it, the next step is to actually model it. Once we have platform, how are we going to offer these platform services, what are different ways or different modes, thinking about how budgeting works. For example, is it are we going to do some chargebacks, are we also going to think about, let's say, are we only going to provide platform services, or are we also going to couple with some consultancy services? uh, are we also going to educate the wider developer community for the faster adoption? Are we also going to, let's say, if you are working in an organization which is a very diverse landscape, then just to give you a concrete example, I was recently working with an organization where they had three different version management systems: GitHub, GitLab, and some other system. Now, it was also as part of the strategic decision, we decided we probably need to converge and use one version control system, for example. And then, as part of modeling, we also said that, okay, so we are going to offer that as a platform service, but we will also couple that with some consulting services, but also help teams to migrate. So, the migration services, because that would basically enable the faster adoption of platform. So that's what we do as part of the modeling exercise. And then the next two phases are actually implementing the pilot. So this is very key and crucial because you really want to get early feedback. So during discovery phase, we also identify who are the right stakeholders, or in this case, which are the right teams who can already pilot with us as we build this platform. So we establish the proper feedback loops and gather that feedback so we can fine tune or pivot our strategy of the platform. And then once that the initial implementation, the next step is to basically expand and scale. So this is on a very high level of what are the 6 stages or 6 steps of implementing platform engineering at a large enterprise. What do we do? I want to just give you a small flavor of what happens in each of these steps. Of course, I'm not going to go through all of them. Let's say just to give you an insight into what we do as part of assessment. We basically assess how current platform vision and what kind of operating models that they provide, which is coupled with the user enablement services. Like how do you enable right now users to consume those services? In some instances, it could be the way of working, the current the process which is currently defined for consuming services. For example, like I said earlier, if the current state is, oh, we have to create a ticket in service now, it has to get a X amount of approvals, etc., etc. So those are the kind of things that we assess as part of the enablement services. And then we actually assess some core technical capabilities, things like the architecture, design, pipelines, compliancy, monitoring and scaling, and those kind of things. And then we also give emphasis on developer experience. How do you make developers' life easy to consume the services without really creating much friction? So don't think friction as just something that they have to like jump through a lot of hoops. Friction can sometimes be like lack of knowledge. I mean, I was working at a customer, and we had to spend a couple of hours just to find the proxy settings, which is not acceptable. A simple thing like proxy settings, finding that information. So that's what developer experience is all about. Am I able to find the information with ease when I need it? And am I able to consume services with ease when I need it? So that's basically boils down to developer experience and how smooth I make it happen. So that's like the broad elements of the assessment that we conduct. And just to give you a glimpse of various elements of operating models, where we explicitly talk about or define how are these capabilities being adapted at a wider organization. I mean, it is no good that we build a really awesome platform, but the adaption of that platform has challenges because either the developer community lacks knowledge or there is a big threshold to get in, or whatever might be the reason. That's why it is important to think about these operating models and explicitly on the capability adoption model. And then in order to help in to make sure that the community is using your platform services in a right way, perhaps they also might need some help from some specialists. This is what I mean by some consulting services. And then, of course, review and supporting services. And a license to operate is also a way that you ensure that anybody can consume a platform, provided that they adhere to certain uh, threshold. Um, the next, of course, as a platform, you have to offer the core platform services, which are provided in a self-service manner. Of course, nothing is easy. Obviously, there are also some common challenges when you implement platform engineering. Couple of things I've listed here, which I've seen, and I've seen some organizations where they've implemented really good platform engineering principles and they offer really good services, but they fail to communicate value. So what that leads to is typically they are always treated as a cost center, and that means the amount of budget they probably can use for innovation or enhancing their platform sort of diminishes because they if they don't communicate what value they are adding, yeah, obviously, so that sort of leads to all sort of challenges in terms of really using uh, the innovation part of it. The next one is not listening to your customers. So you can build a great platform, but if you don't have those feedback loops, yeah, then there will always be some sort of a mismatch between what your developer community is expecting and what you are providing them. And that leads to lack of adoption strategies because depending on when things are changing, you probably also need to adapt and pivot your strategies. And like I said earlier, one size doesn't fit all solutions. If your technology landscape is quite diverse, kind of things, let's say, for example, if you're working with a low code, no code platforms compared to a custom development, the kind of platform services that are expected from the developer community also varies. So there is no one size fit all. And the other thing is lack of ensuring the standards and compliances are baked into the platform itself. So the insufficient guardrails. So that when you don't have proper guardrails implemented in the platform, then you are opening up doors for your consumers to misuse or use it in an unintended way, your platform services. And one of the most common challenges or common mistakes that I've seen is making platforms mandatory. So the moment you make platform mandatory, so it brings up all sort of frustration in the organization. So don't do that. Make your platform in such a way that where your end users, which are developers, are more motivated to start using the platform. And poor communication and collaboration is also yet another challenge where if you make some changes to platforms, new updates, if those are not properly communicated for your users, that leads to, again, frustration. Same goes for lack of metrics. When you don't know how much of your platform is being used, how well it is being used, what kind of SLAs are being adhered, that sort of also leads to sort of frustration. So if you look at, for example, Azure, they also have some sort of like a metrics dashboard, like a health board, where it also talks about the health of their services. As an end user, it is quite useful for me because I can do a lot of things with it. Maybe I can monitor it, I can create alerts and everything on top of it. So making sure those metrics you don't only not only you capture them but also make available to your end users. If you are not doing it, yeah, that leads to some problems. So these are some of the challenges that I've seen with respect to platform engineering. So in a nutshell, So platform engineering is a core building block for any IT organization for successful and reliable value delivery. And as you meant, as you've seen, it's a long-term investment, and it requires developers to, especially the platform developers, to pay attention to the core elements such as security, reliability, scalability of their platforms. And once you have a platform, always start treating this as a product. Like whatever the type of feedback loops that you think about product, like your product adoption, your customer satisfaction, and need for innovation, all those things also need to be taken into account for platform engineering. So I hope I've given you enough insights into what platform engineering is and what are the various elements of platform engineering and how to get started. If you have any questions or if you need any help to implement platform engineering in your organizations, I'm more than happy to help. You can find my contact details there. I thank you all again for the participation, and look.